In this third video on protein, we're going to be looking at how dietary protein intersects with health concerns. There are two main dietary protein health-related concerns that we'll be talking about. The first one is overall protein intake. So how much protein are you getting overall? Are you getting enough? Are you getting too much? The need for protein is going to vary from individual to individual, primarily by age, body size, level of activity, other things going on. If you are bodybuilding or pregnant, you may need more protein. But in general, on average, the acceptable macronutrient distribution range for protein is 10 to 35% of your calories coming from protein. So roughly about a third or less of your calories coming from protein. The second overall concern related to dietary protein that we'll be talking about is the essential amino acids. Now remember that an essential nutrient is a nutrient that your body cannot make by itself, so you need to get it from your diet. And there are some amino acids that are classified as essential amino acids. Your body cannot make them, and you need to get them from your dietary protein intake. Let's talk about total protein intake first. It is possible to not get enough protein in your diet, and sometimes if you are trying to eat vegetarian, or particularly if you're trying to eat vegan and not consume any animal products, you may run the risk of potentially being protein deficient. But typically in kind of a stereotypical American diet, the main concern is getting too much protein in your diet. There tends to be this message that we hear in the US about like, oh, protein, 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 you got to get your protein. And a lot of people do really well at getting enough protein, and in fact get more protein than they need. And there are reasons to be concerned about that. Number one, if your protein is coming primarily from animal sources, you have to be concerned about the fat that is frequently associated with that protein. Think of like a nice, richly marbled steak, for example. That marbling is fat. And animal protein, animal fats coming from animals are more likely to be saturated fats, the less healthy fats as well. Vegetable protein is not associated with fats and may in fact help lower blood cholesterol levels. So vegetable protein tends to contain what are called phytosterols. I'm going to write that word out just so that you can see it. The prefix phyto referring to plants, sterol meaning that it's a cholesterol-related molecule. But these phytosterols found with vegetable protein sources may actually block cholesterol absorption, so they may reduce cholesterol intake from animal sources if you have them at the same time. So getting at least some of your protein intake from vegetable protein is a great strategy for a healthy diet. Another reason to be concerned about too much protein is that there's some suggestion that an excess of dietary protein may actually promote osteoporosis. You'll learn more about osteoporosis when you learn about calcium, but in brief, osteoporosis is illustrated down here. It's a condition that develops with age in a lot of people, where the bones, instead of being normal, healthy, and packed with strong bone structure, they become porous. That's where the name porosis comes from, and osteo means bone. So osteoporosis literally means like spongy bones. Your bones are full of these air pockets and they become weak and brittle and very easily broken. This is something that the likelihood of developing osteoporosis increases with age. We'll talk about other risk factors later in the quarter. But osteoporosis can be very difficult to deal with. This is a little bit of an iffy relationship. By the way, it is a controversial relationship. There's basically observational data that an excess of dietary protein is associated with elevated levels of osteoporosis, elevated risk of osteoporosis. And it is true that high protein intake can increase excretion of calcium from the body. But on the other hand, on the flip side, protein is necessary for healthy bones as well. In order to develop healthy bones, you need to have protein. That's part of what makes bones strong. So the moral of this story is everything in moderation. You do need to make sure that you are getting an adequate amount of protein to keep your bones healthy, as well as everything else in your body. But be cautious not to completely overdo it. And excess protein isn't the only thing that can increase calcium excretion. Also, excess sodium. So if you have high salt levels in your diet, that can increase calcium excretion. Excess caffeine. And even excess fiber can increase calcium excretion. So again, everything in moderation. Fiber and protein are both very good for you, but you can overdo it. The third factor that makes consistently getting too much protein a little bit problematic is that excess protein is stored as fat. Protein is an energy-containing macronutrient, and just like if you take in too many carbohydrates or more lipids than your body needs, the energy from these molecules are used to produce fat storage. Sometimes I think there is a belief that if you eat more protein, it'll just be converted to muscle, and that's not true. Excess protein, the energy is used to make fat tissue, just like the energy from excess carbs or excess lipids. In order to build muscle, you need to use the muscle. There's no magic solution. You have to do the exercise to tell your body that you need more muscle in order to build that muscle up. The only thing that promotes muscle growth is muscle use. Right, moving on from total protein intake, let's talk about individual amino acids. There are essential amino acids and non-essential amino acids. Essential amino acids are the ones that you must get from your diet. The non-essential amino acids can be made by the body. As long as you have nitrogen and carbon, hydrogen, oxygen fragments coming from carbs or fats. Some non-essential amino acids can also be made from other amino acids. Tyrosine is an example of this. Tyrosine is a non-essential amino acid, but actually really tyrosine is what's called conditionally essential. That means that for most healthy individuals, tyrosine is non-essential, but there is a genetic mutation that keeps people from making tyrosine. Generally, phenylalanine, this one, is converted to tyrosine. And that's why tyrosine is non-essential for most people, because it can be made from phenylalanine. As long as you have adequate amounts of phenylalanine, you're good on tyrosine. But if you have a condition called PKU or phenylketonuria, this blocks that transition. It's a mutation in the enzyme that converts phenylalanine to tyrosine so that it doesn't work. People with PKU need to be really careful about the amount of phenylalanine that they take in their diet, because since it's not converted to tyrosine, it can build up to toxic levels and be quite dangerous. All right. So I want to just run through and say the names of these amino acids just so that you hear them once, although this slide does kind of spell them out phonetically like how they sound. So the essential amino acids are histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan. You may have heard of tryptophan because it's gotten kind of a bad rap for making you sleepy after eating a lot of turkey on Thanksgiving. But tryptophan is found in a lot of proteins, and eating too much of just about anything will make you feel kind of sleepy. And valine. The non-essential amino acids include alanine, arginine, asparagine, aspartic acid, cysteine, glutamic acid, glutamine, glycine, proline, serine, and tyrosine, which, as I mentioned, is really conditionally essential. So how do you make sure that you are getting all of the essential amino acids? The extent to which you need to be concerned with this kind of depends in part on what your diet is like. Animal proteins, almost all animal proteins, except gelatin is the one animal protein that is an exception, but all animal proteins except gelatin contain all of the essential amino acids. So if you're getting protein from animal sources, you're going to be getting all of the essential amino acids. It makes sense if you think about it. Humans are animals, and we need all of these amino acids in order to build our proteins. So if we're eating protein from other animals, they've used those essential amino acids to build their proteins as well. So animal proteins, for this reason, are sometimes referred to as high-quality proteins. This is a little bit of a nutrition wonkery term. From a very strict nutritional science perspective, quote-unquote high-quality proteins are proteins that contain all the essential amino acids. It's not saying anything about like the amount of fat associated with it, or where it came from, or whether it was like organic, free range, etc., etc. It is simply defined as proteins that contain all of the essential amino acids. So all animal proteins except gelatin are high quality proteins by this definition. There are a few plant proteins that also contain all of the essential amino acids. Soy protein is a big one. So if you get a lot of your protein from like tofu, for example, you're going to be getting all of the essential amino acids as well. I believe quinoa is another high quality plant-based protein. Now, if you are getting all of your protein from vegetarian sources, there are some essential amino acids that are more likely to be low in your source, in vegetarian protein sources. And this includes lysine, methionine, threonine, and tryptophan are lower in plant sources. There is also a good strategy if you get your protein from vegetarian sources is to make sure that you diversify your vegetarian protein source. Certain plants tend to be good on some essential amino acids, and other types of plants are poor in those amino acids but good in other essential amino acids. So if we just a really classic example of this is legumes like beans and lentils. They tend to be really good in isoleucine and lysine, but they're very poor in methionine and tryptophan. So if you are only getting your protein from beans and lentils, the legumes, you'd be fine on isoleucine and lysine, but you'd be missing out on these two. Grains, on the other hand, are really good in methionine and tryptophan, but low in isoleucine and lysine. So if you were only getting your protein from grains, you would be deficient in isoleucine and lysine. However, if you eat both, if you diversify your vegetarian protein intake and you eat legumes and grains together, you're getting all of these amino acids. You're getting all of your essential amino acids. This is one of the reasons why beans and rice is such a great combination, because you're getting the legumes and the grains together. They are what are termed complementary proteins. Not like, hey, you're looking good today, but complementary with an E, meaning they complement each other. What beans have, rice doesn't have, and what beans are lacking, rice does have. So they're complementary. Nutrition scientists have done research on a variety of different protein sources to work out exactly how good these protein sources are at providing the essential amino acids. I'm not going to try to write this out, but this is referred to as the protein digestibility corrected amino acid score. So what digestibility corrected means is that it's corrected for the ability of your body to break down the proteins. So some proteins are completely broken down by your body, and some proteins your body doesn't quite break them down 100%. So this PDCAS score is corrected for the ability of your body to break down and get all of the amino acids out of that protein. It's calculated by taking the limiting essential amino acid. So that means the essential amino acid that is present in the lowest amount in that protein. How much of it do you get compared to a reference protein? And the reference proteins shown on this list, which is just a very brief list, are a milk protein, casein, and egg white. So both of these are one set to 1, so 1 is the maximum score. You can think of that as being like it gets like the amount of the essential amino acids in these two protein sources is set to 100%. And then each of these numbers here is some percentage of the amount of that amino acid found in milk protein, in casein, or in egg white. So you can say soybean, like I mentioned, soybean is a high quality protein, very high. I don't have a record for which exact amino acid this is looking at. I think, yeah, anyways, soybean is an essential, it is high in the essential amino acids, so it's basically as good as these animal-based sources. Beef is pretty good as well. When we're looking down at different varieties of vegetarian sources, you can see that whole wheat only has about 40% of the essential amino acids compared to these reference proteins. So that just gives you an idea. If you are really interested, you can find the PDCAS value for different proteins. But by and large, if you are getting your protein from animal products, or if you are eating a variety of plant-based proteins, you probably don't have to worry too much about getting all of the essential amino acids.